So I'm going to be talking about theoretical physics, and well, have you ever wondered about the universe or how it works, or have you ever wondered about life and nature and natural phenomena? Well, that's exactly what theoretical physics aims to explain. So theoretical physics is a branch of science that uses known information and certain mathematics to try to explain certain phenomena such as gravity, wormholes, black holes, and more. So one branch of theoretical physics is the explanation of dimensions. And dimensions are basically space-time in which a subject lives. And there are 5 different known dimensions, the 0th to the 4th dimension. The 0th dimension is a dot, a location that has no length, width, or height, and it's just used to represent a point somewhere, but it doesn't actually have any space in it. First dimension is a line, and it's made up of an infinite amount of points. As you can see, the line is white and the dot is black, meaning to show that the line is made up of an infinite amount of dots. Second dimension is a plane, which is made up of an infinite amount of lines. And the lines is black to show that it makes up the plane, and the line is made up of an infinite amount of dots, so the plane is made up of an infinite amount of dots as well. And the third dimension, the one we live in, is made up of an infinite amount of planes, which is made up of an infinite amount of lines, which is made up of an infinite amount of dots. Now, fourth dimension is a tesseract, and any attempt to project the tesseract is incomprehensible. If I were to show you a picture of it, you wouldn't still know how it would act in the actual fourth dimension. Charles Howard Hinton realized this puzzle, this pattern, and he said that we may say that space is that which limits 2 portions of higher space from each other, and that our space would generate the higher space by moving in a direction not contained within itself, which basically means that every dimension is made up of an infinite amount of previous dimension, and every dimension is made when the previous dimension expands in a direction not contained within itself. And so it's kind of impossible to actually comprehend the fourth dimension, but this logic could be applied to it, and we could at least attempt to try to understand it. And next is quantum foam. Now, quantum foam, if you can imagine, is the fabric of that universe. Imagine if the universe were knitted like a sweater and it was actually made up of fabrics. If you were to take one fabric and pull it, the entire universe would be disassembled. And quantum foam, as you can see, is the actual space-time curvature and how gravity and energy affects our universe. And there's been proof of quantum foam that UC Davis researchers have discovered. Their MAGIC telescope detected that certain low-energy photons that were emitted from Markarian 501, a distant galaxy, arrived 4 minutes earlier than the high-energy photons, which actually contradicts Einstein's theory of relativity. And so this broadens the scope of actual theoretical physics, because if this contradicts Einstein's theory of relativity, then there's possibly a disturbance in the quantum foam that made those photons arrive earlier than the other ones. And with quantum foam comes wormholes. Now, wormholes, as you might know, are basically when space-time curves to create a tunnel, as shown in the picture. Wormholes are generated at a quantum level because at the quantum level, things are so small that they could actually break the laws of physics sometimes, because at the quantum level, new items appear and disappear within a second. Items exist in multiple places at the same time. Items affect each other. And actually, one scientist thinks about maybe expanding the quantum wormholes and expanding it to classical size. Quote, "One can imagine an advanced civilization pulling a wormhole out of the quantum foam and enlarging it to classical size." This was from the Physical Review from the California Institute of Technology. And basically in that Physical Review, they speculate about wormholes. And while they may not be possible, scientists can figure out the mathematics to actually make a wormhole possible. Even though it might not be possible in real life, we can still speculate about it actually existing. And so, in conclusion, theoretical physics is a branch of science that attempts to explain natural phenomena, and it tries to explain dimensions, wormholes, and quantum foam, 3 areas which we still need to expand on. And it's very important because these are the things that drive our universe. These are the things that give us the mysteries of the universe, and we need to try to solve it. And with theoretical physics, we can explain nature in a way that we never have comprehended for our existence. Thank you.